All right, this is our Darwood King with Samson Community College. The class is ELC 118, National Electric Code. This is Tuesday, October the 5th, 2021. And we're picking up in our book in Article 220. Y'all help me remember. We finished that calculation Thursday, didn't we? I think we did. That showed a cooktop and then two ovens. I think we finished it, yeah. So we click on, and so we're continuing on page 167, where it says 220.56. For those of you watching the video, 220.56, of course, you see it on the screen. Kitchen equipment load for commercial installation. 220.56 can be used to calculate the demand load for thermostat controlled or intermittently used commercial kitchen equipment like electric cooking equipment, dishwasher, booster heaters, water heaters, and other similar kitchen loads. The kitchen equipment feeder service calculated load must not be less than the sum of the two largest kitchen equipment loads. The demand factors of 220.56 do not apply to space heating, ventilating, or air conditioning equipment. So your demand factor that table 220.56 tells you that based on how many pieces of equipment that are in that commercial kitchen, what is your demand factor? When can you start to reduce the percent based on the number of pieces of equipment? So when you get to 3, it begins to let you knock it down to like 90%, and at 4 pieces of equipment, 80% and so on. Because they figure, you know, that you're not going to run all of them at the same time. It's not likely you would run all of them at the same time. What is the service demand load for one 15 kilowatt water heater, one 15 kilowatt booster water heater, one 3 kilowatt oven, and one 2 kilowatt deep fryer in a commercial kitchen? So how many loads do we have there? You know, you got 1, 2, 3. You got the water heater, a booster, an oven, a deep fryer. So you got 4 loads. So it says that your calculated load cannot be less than the sum of the 2 largest ones. The 2 largest ones were 15 kilowatt apiece. So your total can't be no less than 30 kilowatt. And so they did a total. You do it 2 ways. You go ahead and do it the normal way by doing all of your loads and then doing the 80% based on 4, which gives you 28 kilowatt demand. And hey, how you doing, Melvin? Pretty good. So you see, when you do it, when you count everything, and you count the demand load, then it's going to be 28 kilowatt. Your condition up front says that the total can't be less than the largest 2 combined, right? Which would be 30 kilowatt. So you got to go with 30 kilowatt, don't you? You can't use 28. Because they figure you're probably almost always going to have at least 2 of them things on at the same time, right? That's very likely. From a guy that runs the kitchen, yeah. Okay, so we're on page 167 for those that just come in. How you doing? Glad you made it. Okay. All right. Any questions or comments about that? Starting to get clear, ain't it? You're getting in the swing of how this stuff is done. Okay. If two more loads are unlikely to be used at the same time, only the largest load is used for load calculations. Neutral load for feeders or services. The neutral load for feeders or services is based on the maximum calculated load between a neutral conductor and any one-phase conductor. Line-to-line loads do not place any load on the neutral conductor, therefore, they're not considered in the calculation for neutral. So what do we mean by that? We're going to show you a diagram in a minute and what that exactly means if it's not clear to you. So our question would be, what is the minimum neutral size conductor for a 200 amp feeder that has 100 amp line-to-line loads? Line-to-line would mean like if you got the 240 volts coming into the panel, single phase panel, 240 volt coming in, and say all of your cooktops and your stoves and all, they run on 240, right? 230 or 240. The two hot wires that give you 240 will be L1 and L2. Line-to-line loads use L1 and L2 and they don't use a neutral. So your heating elements that's in your cooktops and your heating elements and anything like that, the ovens and all, they don't use a neutral. They use two highs. So the current is actually flowing using L1 and L2 for 240 volt, and there's no neutral current flowing for the heater elements. The only neutral current you would have in that appliance would be running the electronics, possible, like the display or something like that. You know what I mean? But where you would, if a neutral is used in there, if it's used in there, it would be used on the things that are not the heater element. You know what I mean? Like in a closed dryer, for instance, your heater element in a closed dryer, the heater element runs on the line. It runs on the L1 and the L2. There's no neutral current used for the heater elements. But the motor that turns the dryer uses one hot wire and a neutral and a ground. So the motor that turns the dryer does use neutral current. That would be line and neutral current for the motor in the dryer. So you have to count that if it was closed dryer. So anyway, that's the difference between line to line, which using two hots, no neutral, and then the line to neutral will be 120 volt single phase loads that are 120 volt versus 240, because you have to have one hot wire and a neutral for line and neutral loads. So the panel size, the feeder is a 200 amp feeder. That will be your main breaker size, and the panel will be a 200 amp breaker in the big one. And it's using 100 amp line-to-line loads, which would mean, you're using 100 amps, say on stoves, things like that, cooktops, with no neutral, with a maximum unbalanced neutral load of 100 amps. So the 100 amps would be a separate calculation from loads that are using one hot wire and a neutral and a ground, a hot and a neutral for some load in that system, right? So the calculation goes like this. Now, line-to-line loads are going to be this. You got a two-pole breaker here, right? You can tell that that's a double pole breaker. The double pole breaker is using orange and using brown. And it goes out the conduit, but do you see a gray wire or a white wire in that conduit? There's not. So the load for that double pole breaker there is no neutral going in that conduit. That is a line-to-line load, and there's no neutral current involved in that load. Everybody got it? Your neutral wires are down here. Now here, these loads are different. Now let's trace that up here. You got an orange and a brown. That's a double pole breaker, and it's got line-to-line load in there plus neutral. Wherever that goes, it's got a combined load of line-to-line and also line and neutral loads on whatever that piece of equipment is. That makes sense? So that's how you can tell, looking at the panel, which ones are line-to-line only and which ones have neutral currents included. Makes sense? You can tell by the color code. you know, this conduit does have a neutral in it plus 2 hots. 2 hots and neutral. 2 hots and neutral. 2 hots and neutral. But all of your loads up top, every one of them, all 4 of those up top, they're just line-to-line loads. No neutral. Okay, so the calculation goes like this. They're saying that you got 3 alt. The 3/0 means 3 alt. Let's get out your wire chart. Got your wire chart here. The 310.15 B16. The handout. Now, we'll make sure when you get this in front of you, raise your hand. Let me know that you got it in front of you. Okay. Yeah. Got it. Okay. Did any of you try to get online to the NFPA? Like I asked you last week, has anybody got online to be able to view the code book online? If you will, raise your hand. You have. So you're online, David? Great. Did you get all the way in, or? Huh? You made the account. Yeah. Great. Did anybody else set up an account with them? It's free. You did. Great. Anybody else? Huh? You've already got one. So you other guys try to set one up with the NFPA right here. That's the website. You will set up an account. It's free. Free account profile. And then you will search for NFPA 70. The NFPA 70 is the code book. That is the electrical code book. Right here. The NFPA puts out a lot of code books. They put out a 70, a 72. They put out a bunch of different code books. They got a whole, it's unreal how many code books they got. But all of them say NFPA something, a particular number. The 70 is going to be the National Electric Code Book. That's the one you're looking for. You can get free access online to it. So you search for this code book and you look for the option of free access. And you want the 2020 edition. Of the code book. There's options of looking at previous editions. But the 2020 is what you want. North Carolina is adopting the 2020 code this month. They're taking it's took them that long to vote being in Raleigh. It's a political thing that's voted on in Raleigh. And I can show you an adoption map. We won't take time right now, but if you Google the NFPA electric code, NFPA 70 adoption map for the United States, it'll tell you what state is using what code book at the time. Okay, so here we go with our when you look at it's telling you you got a 200 amp panel, okay? A 200 amp service, and the terminals are rated at 75 degrees Celsius. So what column do we go under in the wire chart to pick the wire? Okay, there's 6 columns there. So out of the 6 columns, which 3 columns do we not want to be dealing with? The ones on the right, because what? Because it's aluminum or either copper aluminum mix, okay, on the right side, the 3 on the right. So you stay on the first 3 on the left are just copper wire. And it would be in the center row on the right, which would be the second column, for 75 degrees Celsius. And you're talking 200 amp. So for 200 amp, what size wire is it, guys? Do you see it on your chart? Okay, what do y'all see? 3 off. If it says 3/0, that's 3 off. And the word off, if you look here, I think that's the way it's spelled. It's Old English. It's an Old English term, alt. Somebody Google that, see if I spelled that right. I think it would be with one A. Somehow that don't look right. With one A or 2? With one A? AUGHT. And what does it say as far as the meaning of it? Does it simply mean, I guess it would just mean 0, or it doesn't say. I know it's an Old English term. It's Old English wording, you know. So the zero means off, you know, and it's just some terms that we use in the electrical field, they come from Greek origins, like some of the symbols we use, like for ohms and Ohm's law, the horseshoe symbol for ohms, the horseshoe, it means omega. It's a Greek symbol that means omega. It's some symbols are like, they go way back. This stuff comes from Europe. All of it comes from Europe, you know. Anyway, so you're dealing with a 3-aught wire, 3-aught AWG phase conductors, because it's a 200 amp service. And then it says that you have it wants to know about the neutral conductor. The neutral conductor applies to 100 amps of unbalanced neutral load. That means you're going to have 100 amps of neutral current there. Okay. So how do we figure that out? That the terminals are rated for 75 degrees Celsius. You got that same column, and you're looking for 100 amp wire, right? And so it's a 3 AWG. It's not a 3-aught, but it's a 3 AWG. Everybody okay with that? Okay, good. Permitted reductions. Your feeder service neutral load for household electric ranges, wall-mounted ovens, or counter-mounted cooking units can be calculated at 70% of the cooking equipment demand load as determined in table 220.55. The 220.55, turn to it, if you will, go in your handout for 220 that I gave you, and go to 220.55 chart. 220.55. let's keep reading to see where they're going with this, because the 70% is not shown directly on 220.55 in that chart that I'm seeing right now. I'm not seeing a direct reference to it for neutral load. Neutral load. It's for neutral load. The neutral load itself. It'll be reading that's going to be around that chart in the code book. You'd have to look to find it somewhere in that section in the code book to find that 70% for that neutral. Let's just move on with it. It'll be in there somewhere, but because of our time, we won't take time to try to locate exactly where it is. But you can believe it's in there. The 70% for the neutral wire, you know, they're referring to table 220.55. But I don't see any direct reference on that page there to the neutral. Yeah, it doesn't matter at this point. Let's just move on with it. Let's just move on with it. And because we're running short on time, just take their word for it that it's in there somewhere in the code book pertaining to that table. No. No, it's not. Well, it's but this is only pertaining to the neutral load itself. It's not talking about demand factor for the entire appliance, just the neutral load itself. The demand factors on that page deal with the entire appliance. You know what I mean? Okay. Not just the neutral wires. Yeah, it's okay. We don't have to know exactly where they got that from right now. To just, you know, to take the word for it. Right. Yeah, let's move on because we're just time's ticking. Just take their word for it. Unless we find that there's a typo in something, we're going to assume everything's okay. There are some typos in there, and when I find them, I do bring it up. You know. I think it's probably because there's 3 units. I think it could be because there's 3 units. Because there's 3. Yeah. Well, they don't really tell you specifically right there. Oh, like you said. They're not. Yeah, it doesn't. We're not being specific for 3 of anything. It's just saying neutral loads can be calculated at 70%. Somewhere in that code book, it's going to be in there in that article. We don't need to have to look it up right now. So our example would be, what is the minimum neutral load for 9 12 kilowatt household ranges? 9. Now, so go to 220.55 to that chart, and we have to use that now for 9. And you're looking at column C because, well, they're how many kilowatts a piece? They're 12. They're 12 a piece. They're not more than 12. And so everybody got your table in front of you, 220.55. Okay. So you're in column C because it's 12 kilowatt, and there's 9 of them. So what is our demand factor? 24%. 24%. So you're taking, 24 kilowatt, not 24%, 24 kilowatt. You got to watch me here. 24 kilowatt, and they're gonna use the 24 kilowatt, and they're gonna reduce it at 70% just for the neutral wire. Okay, the 24 kilowatt is the rating for the hot wires. Okay, when you're rating the size of that of the feeder for that. Okay, but the neutral wire is going to be 70% of that. Now, here's a typo that's in the book. You can write this down. This is a mistake. The 24 kilowatt times 70%, it equals 16.8 kilowatts, not amps. It's kilowatts, not amps. It's corrected in your book, and I can prove it. The next example in the book we're getting ready to do has it right in there. This in here, they got the unit wrong. That unit is supposed to be kilowatts. Kilowatts. There ain't no way you can take kilowatts times a percent and end up with amps. The only way you can get amps out of that is take kilowatts divided by voltage will give you amps. If you wanted to know what the amps is, the amp size of that neutral wire, what do we do? The neutral wire will be sized at 6.8 kilowatts. So watch this right here. .8 kilowatts divided by what will give us amps? Let's see if it's a 240 volt circuit, okay? The voltage is 240 volt. When you divide kilowatts by volts, it's going to give you amps, okay? That's how you would arrive at your amps, okay? You gotta go an extra step to do that. We're assuming that the voltage for those ranges would be, it would have to be 240 volt, 230 or 240 volt, right? So if you figure it like this, what is look, it would be equal to 6,800 watts divided by, you can't even read this. This marker is no good. I got a green here. That's even worse. That's brand new marker. .16 16.8 kilowatts equals, if you go to regular wattage, you're going to add move the decimal over 3 places, right? It'll be 16, 6, 8, 2. Move it over 1, 2, 3. It would be 16,800 watts. 16.8 kilowatts is 16,800 watts. Y'all okay with that? Divided by 240 volts. 70. How many? 70. 70. So it's 70 amps. So if you wanted to know the amp size of the neutral wire, it would have to be a 70 amp rated wire. Okay, you know what I mean? When it comes down to picking, well, really what size? When you say 16.8 kilowatt neutral wire, you still don't know what size wire it is, right? So what size wire is it? What size wire is it if you go to the wire chart? 70 amps, and let's stay in the 75-degree column. Oh, yeah, that's right. And you see it's what now? Okay. It's a 4 AWG for neutral. So look at here. It would be a number 4 AWG wire. Everybody okay with that? That would be the neutral wire. Everybody okay with that? Did y'all make a correction in your book that this is not supposed to be amps, it's supposed to be kilowatts? The next example is actually done right in the book. They do the next one right. The feeder service neutral load for household electric dryers can be calculated 70% of the dryer calculated loads in accordance with 220.54. So go in your handout and look up 220.54, which would be before that. And that chart is for clothes dryers only, not stoves. Okay, everybody see that? So it's a dedicated chart for clothes dryers. In a 10-unit multifamily building, an apartment complex, you got 5 kilowatt electric clothes dryer in each unit. What is the minimum neutral load for all of these dryers? Okay. So you look up and look, you see what they're calculating. They stay kilowatts this time. You see it on the neutral load. This proves that they did the other one wrong, and I know the other one was wrong anyway as far as the units. I knew that, but here they got it right on the very next one. You know what I mean? They didn't say amps down here. You know, see it? They took for 10 units on your table for the clothes dryers for 220.54. What is your demand factor for 10 dryers? It's 50%. 10 units times 5 kilowatt would be what? How many kilowatt? Before the demand factor. 50 kilowatts. So it will be 50 kilowatts times 0.5. And it was going to give you 25 kilowatts. Now, determine the neutral load. They're telling you could go at 70%. Look, in a clothes dryer, like I said before, in a clothes dryer, you got heater elements that heat up to dry the clothes. That's the bulk of the load. It would be the heater elements. They don't draw any neutral current for the heater elements, but the motor that turns the tub does. The timer that times the cycle, the timer uses a hot wire and a neutral, so it's got neutral current. So the timer, your controls, and then the motor, all of those are 120 volt with neutral within that dryer. So you do have some neutral current in there, but it's not a lot. Okay. It's the same number. Wait, set.
Just the number that returned from earlier.
Yeah, they apply it to dryers also. They also apply it to dryers. The engineers that wrote the code book, and there's a bunch of them that wrote the code book. The engineers are dedicated to certain sections of the code book. They've done studies, and they determined that it's okay to do that. It's okay to count that way, even though me and you might not. We may not think that it's common sense, but they've done studies on it. And okay, so 25 kilowatt times 0.7 would be 17.5 what kilowatts, not amps, right? This time, this is my point is, they stay kilowatts the way it's supposed to be. Okay, so 17.5 kilowatt. Now you tell me now, how do I calculate the amps and then the wire size off of that? So let's do that. What do? We have 17.5 kilowatts. So if you the first thing, calculate it, express it in watts instead of kilowatts. You move the decimal over 3 places and you drop the K, right? So it's 17 and put a 5 in there and put a couple more zeros in there. So it's 17 and move it over 3 places. 1, 2, 3. So it's 17,500 watts. Not kilowatts, but watts, right? And then we're going to say 240 volt. That the service is 240 volt. How much?
It's about 73 amps.
73 amps. 73 amps. And then go to your wire chart. What does your wire chart say for 73 amps in the 75-degree column? What size wire? We're looking for, we want a neutral wire that can handle 73 amps. And we're looking in the 75 degrees Celsius column in your wire chart. Which one? I can't hear you. We're looking for the wire size. Yeah. And it's going to be in the 75-degree column in the wire chart. We're going to assume that the terminals are rated at 75 degrees Celsius. So wattage divided by 240 gives you 73 amps. Now, take the 73 amps and go into wire chart. Give me to pull the wire chart up here on the screen so you can see it for me. Let me pull it up on the screen, guys, if it's not clear. Hold on.
He had it right. He just wasn't speaking up, and I started.
He just won't speaking up and up. There goes the chart right there, guys, right there. So we're talking a 75-degree column there, right? And you're talking how many amps? It says 73. So it's just that one right there, and it would have to be what which wire is it? I can't hear you. A 4. Okay, 4. It is. It's a 4. Everybody see that? It's a 4 right there. Everybody cool with that chart? That chart, if you didn't know anything else in that code book, if there was one thing you would need to know more than anything else in the entire book, it would be how to use that chart right there. You use that chart more than anything else in that code book. You can write that down. I've been using it for as far back as I can remember, and it's the one thing that you go to more often than anything. And I don't care what you're wiring up. I mean, you go back to that, almost always. And let's say you look it up a particular cable, not one wire, but a cable assembly with more than one wire, then you go to a different section for that. All right, so let's go back to there. So does everybody agree with that? How we actually got our amps out of the kilowatts? That we're just using Ohm's law there, right? We use Ohm's law for that. And then the next thing would be the feeder service neutral load for a 3-wire single phase. If a 3-wire single phase, you've got a hot, a neutral, and a ground, right? That's 3-wire single phase. Or a 4-wire 3-phase. 4-wire 3-phase would be 3 hots and a ground. 3 hots and a ground. The neutral, well, they're counting the neutral as part of part of that 4-wire on the 3-phase. They're counting that. They must be, because they're not calling it 5-wire. We got a plug out here on a piece of equipment with 5 wires, 3 hots, and neutral and ground. That's they're not counting the ground. They're not counting the ground. Yeah. Yeah.
Whenever you look at the plug mess, it'll have to get the ground without ground.
Exactly. So for cables, you don't count ground. You see, it's a 2-wire with ground, like a 14-2 with a ground or 14-3 with ground. Yeah. Okay, so whether you're dealing with single phase or three phase, the neutral can be counted at 70% of a portion of the unbalanced load that goes over 200 amps. So that's a little catch there. If you go over 200 amps, you can count the excess portion at 70% for the neutral wire. What is the feeder service neutral calculated load for the following? You got 500 amps of line-to-line loads, 100 amps of household ranges, 50 amps of household dryers, 350 amps of line to neutral loads. And so there, I found a typo in the book. Not on this one. On page 169, which we're not going to get to, I don't think, today, but I did find a typo on page 169 on the chart in there. I'll tell you what I found. So anyway, for our calculation here, you have for the 240 volt loads, there's no neutral currents flowing because they're line to line loads like heater elements, you know, for ovens and all. On the range, yeah, because the range evidently is using some neutral current for the controls on the range, you know what I mean? For the display and the controls for the range. It does have some neutral currents in there. Your dryer loads at 70%, and then your line to neutral loads at 100%. So they added up and you got 455 amps. It's above 200 amps, so the excess above 200, you can figure it at 70%. So they're taking the total of 455 amps, and they're taking the first 200 amps of it over here to the side at 100%. The remaining 255 amps at 70%, and it's giving you a total neutral load of 379 amps. A total neutral load of 379 amps. And then if you want to figure out the size of the wire, let's see what they're doing here. If you go to your wire chart for 379 amps. 500 kc mil, 500 kc mil wire, which would be about that big around. A big wire, really big wire. I pulled some of that type wire before, and it takes about 3 guys to do it. When you're pulling it with a rope, you run a rope through some conduits, big old 4-inch conduit, and you're gonna pull 4 of them wires through there, 3 of them for 3 phase and 1 for ground. You can do it by yourself. And then about 3 guys, at least 3 guys pulling at the same time on a big old nylon rope. You better take some wire soap and put it on there to slick that wire down and pull it through there. They got soap in it that you squeeze the bottle and you actually lubricate the wire when you pull it through there, so it's come around the corners okay. No reduction in the neutral calculated feeder service load is permitted for the following. You're not permitted to do it for a 3-wire circuit to come from a 4-wire Y-connected system. Now, when we say a Y-connected system, here's all that means, guys. You see the windings right there that look like a Y shape? That's a transformer out in the yard. You go outside and you look out there, you can look out there on our property out there. If you go behind the east building and you look, you'll see a thing out there with some fins on it. It looks like it's a transformer with some air-cooled fins in there. And that transformer is what takes the power off of the power line and steps it down to the voltage that we use in the building. Now, the secondary on that transformer that actually feeds us on the low voltage side is it can be in a Y configuration transformer. So that winding, that picture right there is a transformer that would be feeding a building. So it would be the power company's Y connected transformer that would be feeding your house or your school or whatever, okay? So those transformers can be wired in a Y configuration or delta. The delta looks like a triangle instead of a Y. And so it will be one or the other. Okay. And they're just telling you because of the nature of the way the currents flow in that system, you can't reduce the neutral load without trying to get into the reasons why. Just take their word for it that you're not allowed to reduce the neutral load on a system like that because of the way the currents flow in there. And you can't even tell by looking at that what they mean because you don't really know about what the loads are on this end. You know what I mean? You don't know. There's a lot of unknown in that statement there because this load right here, we don't know what the loads are in this box over here. We don't know what they are to be able to prove what they're saying. You know what I mean? They're not proving by what they're saying what it is. They're just telling you can't reduce it. So you just take the word for it. If you knew more about what was happening over in here, you would be able to explain. Well, that would be a phase. The phase to ground load right there, of course. If you got 200 amps on that, it will be a sync. In this case here, what that will be evidence of, it would be evidence of a line of neutral load, of a 200 amp line of neutral load, not a line load that's actually drawing a current at the moment. You know what I mean? At the moment, whatever's out here, it would be a line to neutral load, not a line to line load, because there's no current. Well, then that's not even true there. They're showing 200 amps on both of those and neutral current. So anyway, there's an unknown about that load. So just take their word for it. Some of this stuff you just got to take what they say and move on. There's a line to neutral current going on there, but it's not explained. Everything's not explained there. Feeder service neutral calculated load is not permitted to be reduced for nonlinear loads supplied from a 4-wire, 3-phase Y connected system. Nonlinear loads are things that are like LED fixtures that's got electronic boards in them. Things like that. Computers are nonlinear loads. They call them nonlinear loads. So computers, LED drivers for lights are called nonlinear loads. Yeah. And their calculation here you don't count the top, but you count the second two, which will be 400 amps. So it's just simply 400 amps. Because the first one was line to line with no neutral involved at all. 200 amps of line of neutral and 200 line of neutral nonlinear loads. That's it. That's the perfect stopping place right there. Part 4, you get into something called optional calculations. And they're actually simpler than what we've been looking at. When you go take a state test, they'll tell you, are you going to use standard calculation method or optional? And on the exam, you got to be able to know what the stuff we just went through. You got to know that method for standard calculations on buildings and all. And then what's coming up on optional, you got to be able to know either one of them, because when you go if you go take a test, then the computer will randomly give you one version and give you another version that's slightly that it might give you one for standard, it might give you one for optional when you're in the same room taking the test. So when I went, it was more based on optional calculations, and I had practiced on both of them, so I was okay. I practiced up on it pretty fresh before I went, and so I was able to switch gears, whichever one they asked for. But those are the two choices when you're dealing with buildings.
The whole test.
No, it's just a portion I'm doing, like calculations for houses and apartments and things like that.
Just gonna give you
One or the other. When you get to say a particular problem, like problem number 10, it might be for optional calculations. Problem number 15 might be for standard calculations. So they can give you a mix, but what I remember was I don't even remember if there was any standard calculations on my exam or not. I don't remember. I just remember optional. That's all. That's one thing that stands out.
It says optional, but yeah.
Well, optional is an optional method. Optional method is simple. When you see it, you'll actually like it better than what we've been doing. It doesn't have all of these what ifs and all that.
So in other words, you don't have to find every chart for every point.
No. It's simple. It is simple, yeah. It sure is. You'll like it better. I like it better myself. So, yeah. Okay. We'll stop. Okay, we're ending for today for the recording. Whoever's watching, if you got questions, you have my contact information. Let me know if I can help you, and you have a great day.